Hi people, notes 5.6 are on solving linear trigonometric equations. And this video isn't going to be super new to you. We're just going to be talking about some more specifics in this lesson. So let's jump right into it. So our first question says to solve this equation right here, 2 sine theta plus 1 equals 0. And it's really important that we take a look at our restrictions. That has to be from negative 2 pi to 2 pi. So first thing I want to do is isolate sine. So I'm going to subtract the 1. And then I'm going to divide by 2. So I end up getting sine of theta is equal to negative 1/2. So the next thing I'm going to want to find is my related acute angle. So I'm going to say sine of beta is equal to 1/2, which means that beta is equal to the inverse sine of 1/2. With these special values, I'm not going to use my calculator, and I'm going to go through and I'm going to look and see where is sine of theta going to be equal to 1/2. And we know that sine of theta is going to be equal to 1/2. It's either going to be at 30 degrees or pi over 6 or at 60 degrees or pi over 3. However, sine is the y value and we want the smaller y value. So this would have to be at pi over 6. And you can always just refer back to your unit circle if you need some help. But just a reminder, this is at root 3 over 2, 1/2, which means that our related acute angle is going to be pi over 6. But if this is our related acute angle, we need to figure out where our actual answer is going to be, because we want to know where sine of theta is going to be negative 1/2. So remember, sine is going to be negative in quadrants 3 and 4. Because it is below the x-axis in quadrants 3 and 4. And our related acute angle is pi over 6 right here, which means, so here this is from negative 2 pi to pi, but I'm just going to look at what happens if I start at 0. So this would give me, right here, my first angle that I would figure out would be, I would be at pi, and then I would add another pi over 6. So 1 pi plus pi over 6 is going to become 7 pi over 6. And then for my second value of theta, right here, it would be in this quadrant, quadrant number 4. So this would be pi over 6 less than 2 pi. So I would do 2 pi minus pi over 6, which would give me 11 pi over 6, because 2 pi is 12 pi over 6. Take away 1 pi over 6 from that, we've got 11 pi over 6. So now we've gone from 0 to 2 pi, but I need to go from negative 2 pi to 0 as well. So here, the next angle that I'm going to figure out right here would be if I'm going backwards this way. So this time, I would be starting at 0 and going backwards, I would end up getting just negative pi over 6, because that would be in quadrant 4. And then if I keep going around this way, this would bring me to negative pi, but this is pi over 6 shy of that value. So what I would do here to find out this angle right here is I would figure out what pi over 6 shy of pi is, but then just make that answer negative. So this would become negative 5 pi over 6. And that should make sense to you. Because it's just short of negative 6 pi over 6, which is a whole pi right here. So then if I were to write out my solution in numerical order from least to greatest, it would be from negative 5 pi over 6 to negative pi over 6 to 7 pi over 6 to 11 pi over 6. And this would be my full solution from negative 2 pi to 2 pi. I want to show you how to check this graphically. So what I would do on Desmos is I would say y equals, and then I would just type in the left side of my equation, which was y equals, which was just 2 sine x and then plus 1. So I just put this in for, I just said y equals on this side right here. And then I'm just going to find my roots, because this is equal to 0. So that would be where my roots are. I want to also say, though, that this is going to be from negative 2 pi to positive 2 pi. So it would open up my set notation brackets. And then I would say from negative 2 pi is less than or equal to x is less than or equal to 2 pi right here. So it shows me only the pieces that I'm looking for. And then I can just find out what all my roots are. And if you notice right here, these are the exact same answers that we got. So we know we did this one right. Okay? Now, one thing I want to say before we move on to number 2 is this this domain that we are given right here is in radians. So that means that our solution needs to be in radians. If you notice our next one that we're going to look at right here, this is in degrees. So our solution is going to need to be in degrees. Okay. So I'm going to do the same thing. I'm going to isolate this time tangent. But before we do that, I just want to write a quick reminder that tangent of theta is equal to sine of theta over cosine of theta. And because we're solving an equation, we have a restriction. And our restriction is that cosine of theta is not allowed to be equal to 0, because then I would have 0 in my denominator here. When is cosine theta equal to 0? It's equal to 0 up at here at pi over 2 and down here at 3 pi over 2. But since we're talking about degrees, it's equal to 0 at 90 degrees and 270 degrees right here. That's where x is 0. So that means that theta will not be allowed to be 90 degrees or 270 degrees. It's really important that we write this down, because if we get solutions with these restrictions, then we wouldn't be allowed to use them at all. Okay, now that we've done that, we can go ahead and isolate isolate tangent of theta. So the first thing I'm going to do is distribute the 3 through. And then I'm going to subtract the 3, I get -1, and then I'm going to divide by this 3 right here. So that means that tan of theta would be equal to -1/3. Now I'm going to find my related acute angle. So I'm going to do tan of beta is equal to 1/3, which means that beta would be equal to the inverse tangent of 1/3. So now when I do this, this isn't one of our special angles, so I actually need to go to my calculator. And I have to make sure that I am in degree mode, because our domain is in degrees, 0 to 360 degrees. So I'm going to take the inverse tangent of positive 1/3. And I end up getting 18.4349, blah, 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 blah. Now this is says to do it correct to 1 decimal place. With degrees, it's easy because we're only going to be adding and subtracting from like 0, 180, 360, as opposed to pi, which is an irrational number. So we don't have to worry so much about our rounding here. But I still would just suggest that you go out as far as you can. So I would say like maybe 18.4349. But if you know how to store angles in your calculator, it will make things so much easier for you as you're trying to solve your answers right here. So for example, here I can go in here and I can just say that this would be, instead of beta, I would just say B. So I would say B equals. So now when I need to use this angle, I can actually recall it by typing in the letter B. So now I have to figure out where my actual answer is going to be, because right here, tan of theta is -1/3, not positive 1/3. We know that tangent is negative in quadrants 2 and 4. And we also know that our related acute angle is going to be about 18 degrees, right? So actually here, instead of writing about 18 degrees, I'm just going to say beta. These are my related acute angles. These are beta. So to find my first answer for theta, all I'm going to do is take 180 degrees, which is right here, and subtract beta from that, where we know that beta is this 18.4349. So I can actually go into my calculator and I can type in 180 minus, and then I can put in my rounded answer, 18.4349, or I could actually just say 180 minus capital B, and then it will use that answer, and I get 161 point, and it asks us to round to 1 correct decimal place, so we would say it's 161.6. So there's our first answer. Our second answer lives in quadrant 4. So this is our quadrant 2 answer. Our second answer lives in quadrant 4, and this is 360 degrees. So it's beta shy of 360 degrees. So I would type that into my calculator, and I can just go in here and just delete this 180 right here and change this to 360. And then my answer would be 341.6 degrees. And these are approximations. So my two solutions, because we're going from 0 to 360, are going to be 161.6 degrees and 341.6 degrees. And then we are good to go for this question right here. Okay, in number 3, we're asked to solve cosecant x plus 6 equals 1 minus 3 cosecant x, where x is between 0 and 2 pi. So this is going to be in radians, and these are always the nicest ones because 0 to 2 pi is just one revolution around. So I don't have to worry about going another revolution around or going backwards or anything. So for starters, we still have to talk about our restrictions just like we did before, because remember, cosecant x is 1 over sine x, which means that sine x is not allowed to be equal to 0. Where is sine x equal to 0? It's equal to 0 at 0 and at pi. So x is not allowed to be 0 or pi. So if we get that in our solution, that means that we would say that it's extraneous. It doesn't work. It's not possible. Okay, so let's go ahead and isolate cosecant x right here. So we are told cosecant x plus 6 equals 1 minus 3 cosecant x. So I'm going to add 3 cosecant x right here. So I get 4 cosecant x, because remember, this is just 1 cosecant x. And then I'm going to subtract the 6 from here, and I would get negative 5, okay? Then to isolate cosecant x, I would divide by 4. Beautiful. But here's the thing, I don't really love solving equations with cosecant in it, so instead I'm going to solve for sine. And remember, sine and cosecant are reciprocals, which means that I'm going to take the reciprocal of this number right here for sine of x. So here I'm going to say sine of x is equal to negative 4 over 5. Okay, cool. So now that I've done that, I need to find my related acute angle. So here I'm going to say sine of beta is equal to 4/5, which means that beta is going to be equal to the inverse sine of 4/5. Let's figure out how much that's going to be approximately. This time I need to switch to radians, and I'm going to do the inverse sine of 4 over 5. And when I do that, I get 0.92729, so on and so forth. So I'll just write down 0.9273. However, if I store this into my calculator as beta, and if you want me to show you how to store things in your calculator in class, I would love to show you, because that will help you to get more accurate answers, because then it'll recall the exact answer as opposed to the rounded answer that we would type into our calculator. But the problem is, again, sine is negative. So we have to use this to help us determine what quadrants we're looking at. And since sine is negative always in quadrants 3 and 4. So this right here would be our beta, and this right here would also be our beta. So our first answer for theta would be pi plus that extra beta, or pi plus 0.9273, or pi plus this exact answer right here. So I can type in here that it would just be pi plus beta, and I'll just put a plus sign in between right here, and I get 4.06 blah, 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 blah. It asks to round to 2 decimal places, so I would get 4.07 approximately. Okay, and then the other solution would have to be 2 pi right here, but it's beta less than that. So then when I type that into my calculator, Desmos is amazing because I can just go through here, type this in as 2, delete this here, subtract it, and I get 5.36. So that means that my two solutions would be 4.07 and 5.36, because again, I only have to go through and do one rotation around the coordinate plane. I want to show you how to double check to make sure that this is right. So for starters, the right side of my equation is going to be my first line in Desmos, y equals cosecant x plus 6. The right side of my equation is going to be the other line that I have in Desmos, 1 minus 3 cosecant x. Let's go ahead and see what that looks like. So here I would type in cosecant of x plus 1. And then I would also change my restrictions because it says it only needs to be from 0 to 2 pi. And sorry, I meant to say plus 6, so let's fix this to plus 6. And then the other one is y equals 1 minus 3 cosecant So put 3, type in functions, type in cosecant x right here. And then I'm also going to do that restriction. So here I'm going to say from 0 to 2 pi. And then where do my two graphs intersect with each other? What are the x values where they intersect with each other? 4.07, which was our first solution, and then 5.36, which is our second solution. We don't include the y value because I don't want to know what this cosecant plus 6 is right here, or this 1 minus 3 cosecant. I don't want to know what the output is. I just want to know what is the value of x that's going to make them both the same as each other, which again are 4.07 and 5.36. All right, people, the last one, sine of 4x equals 1/2. So this one is a little bit trickier. We've talked about this before, but let's talk about it again just to really solidify your understanding right here. So first things first, we have to look at this domain restriction right here. So this is what x is, but in our problem, it says sine of 4x. So what I need to do is I need to make a new domain restriction. And I need to figure out what's going to happen if I have 4x. So since this was multiplied by 4, I multiply every single other piece by 4. So that means that 4x lives between 0 and 8 pi. So the next thing I'm going to do is I'm going to let u equal 4x. Again, if you don't like to use the u, you can skip this step. You don't have to do this piece. But I know that for some people, it simplifies things a little bit. So right here, we would say sine of u equals 1/2. And then I'm going to find all the possible, remember u is 4x, so I'm going to find all the possible values of u from 0 to 8 pi. So u would be equal to inverse sine of 1/2 right here. So I would use the unit circle and I would see that 1/2 would occur. My related acute angle would have to be at pi over 6. And then because sine is also positive in the second quadrant right here, I'm going to also have a solution that is at 5 pi over 6 because I just subtract pi over 6 from pi, okay? But I need to keep going around. I'm going to go around and around and around in my unit circle. So I've gone around once. Now I'm at 2 pi. So my next answer right here would be 2 pi plus pi over 6. And 2 pi is 12 pi over 6. So this would end up becoming 13 pi over 6. Again, if you need help with the fractions, come see me individually. The next answer would be here at 3 pi. So then I know that my next answer would have to be 3 pi minus pi over 6. And 3 pi is 18 pi over 6. So this would be at 17 pi over 6. I have to keep going all the way until I get to 8 pi. So now let's do the next one. So I just move this down a little bit so that way we can kind of see what's going on right here. Our next one, so we were at 3 pi. We have gone all the way around twice now. So here, now we're going to be at 4 pi. So my next value right here, my next solution would be 4 pi plus another pi over 6. So 4 pi is 24 pi. Add another pi over 6, I get 25 pi over 6. And then the answer over here would be at 5 pi, but it's pi over 6 less than that. So I would do 5 pi minus pi over 6. And 5 pi is 30 pi over 6. Subtract pi over 6, I get 29 pi over 6. If I were to keep going, that would bring me back. So I've gone around 3 times now. So now I'm at 6 pi. So my next solution would be 6 pi plus another pi over 6 right here. And 6 pi is 36 pi over 6, so I get 37 pi over 6. And since that's 6 pi, then this would have to be 7 pi. So my next solution would be 7 pi minus pi over 6. 7 pi is 42 pi over 6, so this would become 41 pi over 6. And now I've gone around 1, 2, 3, 4 times. This brings me to 8 pi right here. I've gone all the way around. So I have found all my possible solutions for you. So another way to think about this is, if you remember, in every rotation, we'll always have 2 answers of sine that would be positive, one in quadrant 1, one in quadrant 2. The next rotation is just a full period away, which is 2 pi. So if I add 2 pi to that, I get 13 pi over 6. If I add 2 pi to that, I get 25 pi over 6. So this is another way to think about it if you would like to do it this way. And I'm actually going to show you a third way to think about it when we get to our final answer. So I can add 2 pi, add 2 pi, add 2 pi every single time, okay? However, this is what u is, and we know that u is 4x. So I'm just going to cross this off and write this down as 4x because I don't feel like writing all 8 answers down, which means that to solve for x, I need to divide everything through by 4. And when you divide by 4, it's the same thing as multiplying by 1/4. So if I take my first answer of pi over 6, divide it by 4, I'm multiplying by 1/4. So I get pi over 24. So my first answer here would be pi over 24. The second answer, I would be taking 5 pi over 6, multiply that by 1/4, I'd get 5 pi over 24. And then if I keep going, my next answer would be 13 pi over 24. I am color coding this in 2 different colors on purpose. I'll explain why in a minute, but let's just go ahead and write out all of our solutions first. So we get 25 pi over 24. I'm going to skip and do the next one in red. So I'd get 37 pi over 24. And then my answer that corresponds with this 29 pi over 6 would give me 29 pi over 24. And then my last one would be 41 pi over 24. And these right here are my solutions, okay? However, I just want to show you another way to think about this if you would like another way to think about it. So here, if you notice, this k value right here is 4. So our period would be equal to 2 pi over k, which is 4, which is pi over 2. So that means that I could just add pi over 2 every single time. So to go from here to here, I could add pi over 2. Pi over 2, remember, is 12 pi over 24. So I'm just adding 12 pi over 24 to 13 pi over 24. Do it again to go from here to here, here to here. That's how you get those answers. That's another way to think about it. So you can just figure out these first 2 answers, divide it by 4, get these next 2 answers, and then just add a period. And then same thing here, 5 pi over 24 to 17 pi over 24. We're adding pi over 2 or 24 or 12 pi over 24. Last thing I want to do really quickly is just do a solution, or just do a check of our solution graphically. So here on one side, I would write down y equals sine of 4x. And then here on the other side, I would just say y equals 1/2. And if you notice right here, I'm just going to turn this off for a second. If you notice, because it's sine of 4x, we now have 4 cycles within our 2 pi cycle, which should make sense right here. And that's why we will now have 8 answers instead of just our typical 2 answers. So now where are those 8 answers going to be? Let's zoom in and see. So our first answer will be at pi over 24, 5 pi over 24, 13 pi over 24. Oh, look at that. These are all the solutions that we have gotten. And that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class. Bye.